Assalamualaikum and salam sejahtera. We are from Geology Section 3, Group 9. We'll be presenting our fieldwork of Engineering Geology Camp, site visit to Minyak Beku, Air Hitam. Assalamualaikum and salam sejahtera. My name is Nur Wahida binti Radila and my metric number is CF2067. I'm going to begin our presentation with introduction. Geology engineering is a branch of civil engineering that involves the survey of geological condition of a particular area. From the study area, we collect geological information from the rocks such as their types, measurement discontinuities, orientation, and identifying the characteristic of discontinuities. Our study area was located at Minyak Beku, Air Hitam, Johor. From this project, we aim to fulfill our objective, which are increase the knowledge of students about the real rock and classification of the rock at the site, learn how to collect sample of rock and record the data on site, explain the detail about the form of rock in geology engineering, be able to explore more of the rock structure at the slope in the said location, and expose the student on how the geology rock investigation were made through step and method. There are three types of rock: igneous rock, sedimentary rock, and metamorphic rock, which differ by their characteristics such as their origin, formation, structure, and texture. From the site visit, we are able to identify several types of rock that form in the locations such as shale and sandstone, where both of them belong in sedimentary rock.
For the methodology, the apparatus that we use is Bruton compass, is to measure the deep direction and deep angle. Second is measurement tape to measure the length of joint. Third is marker pen to mark the reading. Fourth is digital rebound hammer, is to determine a rock strength on different type of rock and hardness level. Procedure of deep angle. First, take the compass and put down the downside compass to the same level with rock slope to find the slope angle or the deep angle. Second, make sure the value of the bearing deep angle is on the left side. Third is read the value that we achieve. The bearing that have been achieved is steepness of the slope. The procedure of deep direction. Take a small rock of material, then lay the material to the surface. See the direction that the material falls based on gravity. So the direction is the deep direction. And then record the deep direction that we achieve. With a compass, level compass to the north direction and see the value of the bearing deep direction. Every strike or deep direction, the value must be determined from the north. And lastly, the deep direction can be determined using the formula strike plus 90 degrees. The Schmidt hammer test procedure. First, the hammer was pressed against the rocks. The plunger reacted against the spring and the hammer was ready to use. Second, the hammer was pressed to the test location until the mesh hammer impact against the surface through the plunger. Third is hammer was operated perpendicular to the surface horizontally. And fourth, the button at the side of the hammer was pressed and the amount of rebound mass R from the indicator was read. And lastly, by referring the calibration curve on the standard steel anvil, the compressive strength was recorded. And lastly, we estimate the compressive strength.
Ini yang kita buat tadi. Ini yang kita buat tadi.
Dah nak ambil video.
Boleh tumpang video.
Boleh.
The procedure of point load test is first, the rock sample were collected from the same type of rock where it peaked at Air Hitam, Johor. Second, the rock sample underwent the shape prescription where its distance and width were measured to make sure it fulfilled the criteria to undergo the test. Third is the sample that fulfilled the criteria was subjected to the test using a digital rock strength index apparatus where it would undergo a certain load until it reached breaking point. Lastly, the maximum reading on manometer is recorded for further calculation.
Okay,
Ambil gambar ni juga. Ni batu kerak. 3. The procedure of rock mass writing. First is outcrop preparation is done using the 1 meter multiply 1 meter window method. So using a measuring tape, the rock mass of 1 meter multiply 1 meter is established. Second, the Schmidt meter is used to calculate the SRV at 9 places after a grid line is applied to divide the surface into 9 blocks. Third, for each joint sets, the number of joints is recorded to establish the value of rock quality designation RQD and discontinuity spacing SA. And the condition of discontinuous is determined based on first is persistent, second is aperture, third is roughness, fourth is infilling, and fifth is weathering. And the condition of groundwater are determined based on the gross ice. The orientation of discontinuous also affected by the weather. The strike is parallel to the rock mass or perpendicular to the rock mass. 7. To generate the RMR total rating, all the data is calculated and classified using the rock mass rating system table. And lastly, the rock can be classified in order of excavation.
My name is Siti Nordiana binti Buang with matrix number CF200220. So I will proceed with the next part, which is the data analysis and discussion that in chapter 4. So I will begin with the determination of rocks and minerals that we have found in the study area. So the types of rock that we have found on site is the sedimentary rocks such as shale and sandstone. So what did we know about shale? Shale is a fine-grained sedimentary rock that forms from the compaction of seed and clay-sized mineral particles that we commonly call mudstone. So shale is distinguished from other mudstone because it is fossil and laminated, which means that the rock is made up of many thin layers. So meanwhile, the sandstone is composed of same-sized grain of minerals, rock, and organic material. So it also contains a cementing material that binds the same grains together and may contain a matrix of seed or clay-sized particles that can occupy the spaces between the same grains. So basically, it has a very high quartz content that it might be crushed or used as a source of silica for glass manufacturing. So that is the two rocks that we have found on site in Aihika. So I will proceed with the next part, which is the identification and classification of weathering grade. So during on-site, the structural of rock that we have found, it has 4 grades, which is the grade 3, grade 4, grade 5, and grade 6. So in the weathering profile shown above in the figure that we have seen in the slide, grades 5 and 6 are more likely to be soil. For grade 6 is a residual soil group that is the result of weathering both physical and chemical rock. So the grade 5 and 4 tend to be classified as a soil as it has undergone a change in composition. So for grade 3 is moderately weathered. A slight change in the composition is given in grade 3, where the color change begins and the size of material becomes smaller. So the next part is the geological structure that form on the study area. So we have found 5 geological structure in our study area, which is the first one is the toppling failure, reverse fault, monocline fault, wedges failure, and joint. So what is toppling failure? So toppling failure is a common mode of instability in layered and blocky rock slopes where rock blocks rotate about their toes and overturn. In this failure, rock blocks at the toe of the slope are obtained by the pressure of sliding mass from the upper part of the slope. When the slope rock mass features a set of steeply inclined structural planes with approximately in the same strike as the slope, the rock pillar formed by the cutting structural plane may bend and the slope may undergo toppling failure. So, toppling failure is a typical failure mode of rock slope of this type. So, next one is the faults, reverse fault. So, faults form when the rock is put under so much stress that it can no longer bend but break. There is a crack that forms when rocks break and move past each other called a fault. So in this type of fault, the hanging wall and footwall are pushed together, and the hanging wall moves upward along the fault relative to the footwall. This fault motion is caused by compressional forces and result in the shortening. So a reverse fault is called a thrust fault if the dip of the fault plane is small. So the next one is the monocline. What did we know about monocline? So the monocline is a fault consisting of two horizontal lines connected by a shorter inclined line. So monocline is characteristic of the region in which sedimentary rocks have been deformed by deep slip movement along vertical or steeply dipping faults in the older and deeper rocks. So most monoclines are classified as drape faults or false fault because the sedimentary rocks are draped and forced as a result of movement along underlying faults. So we move to the next geological structure, which is the wedge failure. It is known as a block failure or plane failure generates a failure plane that is inclined. So this type of failure occurs when there are fissures, joints, or weak soil layers in slope, or when a slope is made to different material. So this kind of failure causes a rock mass to slide along two intersecting discontinuities. So this mode of failure needs the dip angle of at least one joint intersection to be greater than the angle friction of the joint surface. So the last geological structure that we have found on site is the joint. So the joint is a break of natural origin in a layer or body of rock that lacks visible or measurable movement parallel to the plane of the fracture. So a joint is a fracture dividing rock into two sections that move away from each other. So this joint does not involve in shear displacement and forms when tensile stress breaches in threshold. In other kinds of fracturing, like in a fault, the rock is parted by a visible crack that forms a gap in the rock. So during the site visit to IHICAP, we determine the dip angle and the direction using on the joint. So it functions as an impart and a well-developed fracture-induced permeability to the bedrock. So I will pass to the next presenter for his part. Thank you.
Hello, my name is Patricia Jonatica. So today I will present about data analysis. So first is speed hammer test. So for this speed hammer test, we take reading of hammer rebound at post P, and then we total it because we take the 9 reading, so we divide by 9, and then we got 22. And then for UCS, and then we find it is 12 by this graph, 12 m per millimeter square. Next is a point load test. So for this point load test, actually is 10 sample, but I only take example picture. So and then calculate divide by 10, and then we get 0.544 megapascal. Next is slide durability data. So we find the rate of empty clean, before and after, and then we find it is 0.91766, and then divide by 100%, and then we got which is 91.77%, and then for based on the selectability index classified, the selectability of the sample is very high. So IDI is 90 until 95. So for the derivative classified, which is a very high, we get it from this table. Okay, so next is rock quality resonation, RQD. So for the number of joint for each joint set is S1 is 11, S2 is 30, S3 is 6, and then S4 is 4. So and then the total of the joint we found it after we calculate is 34, and then the real quality designation is RQD. We found it 2.8 percent. So the average spacing of the continuity that we calculate, we found it is 0.146 meter, and then the condition of the discontinuities is determined based on this table, which is a criteria, condition, and rating. So first is a persistent is over 20 meters. I think it's 0, and then aperture as condition is 1 millimeter, and the rating is 1, and then criteria is roughness. The condition is smooth, and the rating is 1, and then criteria infilling, and the condition is really hard filling, and the rating is 4, and the weathering, and then moderately weathers, and the rating is 3. So the orientation of these continuities is the discontinuities are oriented along a perpendicular axis with a 30-degree angle, and the total rating based on the table. So this from table, which is this one. So after we found the point load, straight index, the value is less than 1 megapascal, the rating is 0, and then for RQD, the value is 2.8%, and the rating is 8, and then the spacing of discontinuities is 0.48 meter, and the rating is 8, and the condition of discontinuity is rating is 5, and the groundwater in term is rating is 10, and the adjustment for joint, and the rating is negative 10, and the with total, all the total is 21, and then we found it. This one is sorry, this one is not. So the rock mass can be S-class, which is a class 4, which is a poor rock, RMR 21 until 40. This the true one. So this for this condition is poor rock. And then data for this data we using brutal compass to find this data. So this data we get it data deep angle and deep direction. That's all for me. Thank you.
Assalamualaikum and hi, I'm Rabiatul Adawiyah binti Nazri. My metric number is CF 2070, and I will continue this presentation with part of conclusion. Okay, in conclusion, we can learn more deeply about the structure of rocks and identify the joints and folds. From these site visits, we also learn more about the rock types, geology structure, and orientation that strongly control rock slope stability. They are required to acquire a true understanding of these parameters mentioned. The field trips really helps our group to learn some of the stuff that we studied during this course, being able to see some real example and having them explain it to us. Other than that, this field trip also helped us to determine the three categories of rock, which is igneous rock, sedimentary rocks, and metamorphic rocks. Based on the data and observation that we do in air hitam, the type of rock that is found is igneous rock and sedimentary rock. Apart from increasing the knowledge, we gain more experience on the site visit. That's all from our groups. Thank you for watching our video presentation.